Welcome, sixth grade class. I know this is a little bit different way to start a class, but I'm at home today and I wanted to make sure that we could still cover a really important topic. So I'm going to need you to make sure that you've got your notes out and that you're ready to take notes on what we're about to talk about. So I'm going to switch this camera around in a minute and I'm going to point it at the page. And as I point it at the page, anything that's on the page, you should have in your notes written just the same way that I am writing it. These are going to help you remember these as we're looking back at this in the future. So your homework tonight, go ahead and pull out your assignment notebooks. Your homework tonight, we are coming up to the end of our chapter. Since we're coming up to the end, that means that we're going to have our quiz on this chapter in the not too distant future. Your homework tonight, you need to make flashcards for all the orange words that were the words to know and the challenge words for the chapter. Those flashcards I want you to review tonight and then make sure that you bring those tomorrow and on Monday to class. Today, we are going to talk about something really, really interesting that doesn't seem interesting at all when you first learn about it. So, let me ask you a question. What is the biggest mistake you've ever made? Now, you don't need to answer out loud. In fact, I'm probably not going to tell you what the biggest mistake I've ever made because it's kind of a tricky question to answer. As far as the NASA engineers in the last 30 years could answer, one of them had to do with today's topic. So this is a story that I'm going to tell you. So NASA created a satellite. That satellite was called the Mars Climate Orbiter. They sent it up, they put it into a rocket, shot it into space, took it all the way from Earth, all the way over to Mars. As they were about to perform a maneuver to put it into Mars orbit so that it could start collecting data, they tried a maneuver. And when they did that maneuver, instead of going into orbit right around Mars like they expected, it crashed into the surface of Mars and we think blew up. Now, why did it happen? The reason why it happened is because there were two places that were building this satellite. It was designed at the Jet Propulsion Laboratory and was built by Lockheed Martin. These two places, one of them, the Jet Propulsion Lab, used the metric units when they were scaling up their model and doing their calculations for how much spin they needed to apply to get it into orbit. Lockheed Martin, on the other hand, used the imperial system. And as a result, their calculations were different from what was expected, and that caused a $327 million mission to literally explode. So be thankful, no matter what mistakes you've made up to this point, you haven't yet made a $327 million spaceship explode. Now, that said, we can avoid this by learning how do we convert between the metric system and the system that you've used in the past. So go ahead and pull out your notes and we're going to take a look at this together. So today we're talking about units. Let's see, can we see that all right? I think so. So as a reminder, if I've got it written here, I want you to put it in your notes. So at the top of your page, we're going to go ahead and make a heading. The metric system. Uh-oh, my pen is thinking it doesn't like this. Oh, there it is. The metric system and unit conversions. It's always good to put a heading on the top of your page. That way you know where to look when we come back to this and have to study for a test. So, the metric system and unit conversions. When we talk about this, scientists are often going to have to work together and come to a system so that everybody can understand exactly what it is that we are working with. Now, In order to talk about quantitative data, we need to have a set way to measure it. Now, in America, we use what is called the Old English measuring system, or the imperial measuring system. So in the Old English measuring system, we used the following units. So these are things like inches, feet, miles. All of these are for length. We also talk about, in addition to that, rod, hand, and span. Now, the only one of these that I'm familiar with that's still used commonly is hands. If you talk to any of the people who do horse riding, they'll talk about how many hands high their horse is. Now, for weight, there are ounces, pounds, and tons. That says pounds. You want pounds. And then for volume, how much space, there's the fluid ounce, cups, pints, quarts, and gallons. All of those measure volume. All right, I'm going to pause here for a second, and I want you to see if you can remember how many inches are a feet, how many feet are in a mile, how many rods, how many hands, oh boy, how many ounces are in a pound, how many pounds are in an imperial ton, how many fluid ounces are in a cup. With your partner, see if you can remember what are the relationships between those things. Go ahead and discuss. All right, now I'm not sure how many of those you were able to remember. Some of you probably remember the relationships between cups, pints, quarts, and gallons pretty well, because we do that a lot in math class. Maybe even ounces, pounds, and tons. Ooh, but feet to miles is a little tricky to remember. Wouldn't it be nice if there was an easy way to remember the relationship between these different sizes? Well, there is. So the metric system is what is standard in all of science. The metric system is also called the Système International. And you'll see that written sometimes as SI units. Now, why did I sound funny? Well, that's my best attempt at a French accent. Very poor, but it's based on the Système International. It sounds a little more Spanish, I think, or SI system. So in the metric system, or the SI system, what we deal with is we deal with multiples of 10. So all units are in multiples of 10. And we start with a base unit. So each type of measurement is based on one standard unit. The three that we're going to look at today are the meter, the gram, and the liter. Now, sometimes you'll see liter spelled L-I-T-R-E. That is the French and English way to spell it, but in America we spell it L-I-T-E-R. So the meter is our measure for length. The gram is the measure for, in this case, mass. And we'll talk about the difference between mass and weight in a little bit. But if we remember from the other day, I talked about what mass was. It's a measure of how much stuff an object has. And then the liter is the measure of volume. And this is not boom. how loud something is. This is how much space an object fills. So if we're looking at this, these units, some of you are really familiar with, and some of you, you're less familiar with this. So to just give you some good estimation points, a meter is around 3 feet. That's a little bit longer than your hand stretched out all the way. A gram, this is a tricky one to measure, but it's about the mass of a paperclip. And then a liter is like a tall cup, maybe one of the biggest cups you have in your house. There are about 3.8 liters per gallon. So these are really close to a pint. Excuse me, to a quart. So the meter, the gram, and the liter are the 3 units, and those 3 replace all of these other ones. Inches, feet, miles, rods, hands, spans, ounces, pounds, tons, fluid ounces. In fact, there are other more interesting units, things like stone that measures mass. And there are a couple other SI units, but we're going to focus on these 3 today. Now, the way that we signify each of these, the meter is always going to be a lowercase m. So Mr. Jacob's height is around 2 meters. Mass is always in grams, and it's a lowercase g. So these are all the symbols. So a can of Coke might be 200 grams of sugar inside of it. Not quite, but somewhere in that range. No, not really. I think there's something like 50 grams of sugar in a can of pop. And then volume, liters. So my fish tank that I will be bringing in on Monday, hopefully, is, I think, about, let me think, 80 liters. And this is uppercase L. Now, these symbols are going to stay the same. But what if we wanted to measure something really, really small? Well, we would put a prefix on the front of those. So the prefixes that we are going to use are the following. All right, are we ready? So these kind of a lot. I'm going to write these for length. So let's say a basic unit is the meter. If I have 1/100 or 1/10 of a meter, that is a centimeter. That is a deciliter. Because deci means 10. This is why decimals are called decimals, because they're all in an order of a tenth. Centa means 100. So if I have 1/100th of a meter, I have a centimeter. If I have 1,000th of a meter, I have a millimeter. If I have a 10,000, a millionth, that's our next one. There is one for 10,000th, but I don't remember it offhand. I have a micrometer or a micrometer. And micrometer actually has a silly symbol. This is a Greek symbol right here. It looks, I'm gonna draw it a little bit bigger down here. It looks a little bit like a funny U. This means micro or 1/1,000,000th of the size. When we get into biology, we're going to take a look and see how many micrometers are different objects. Okay, now let's say we want to go up. If we want to go up, and let's say I want to talk about 10 meters. Times 10 is decameter. And that decameter is DEKA. And these are used a little bit less frequently. Times 100 is hectometer. And that's lowercase h. Times 1,000, we'll use this one a lot, is a kilometer or kilometer. And bigger than that, the megameter. So for each of these, if we take a look, we can see how we're using the same symbol here, the meter, and it's lowercase m in all of these different situations, depending on whether we're going down or we're going up. All right. Make sure you've got all these copied down. Stretch out your fingers. We've been talking for about 15 minutes. I want you to go ahead and pause the video. Get up, stretch your fingers, touch your toes, go fill up your water bottle if you need to, and come back right now. Okay, so hopefully you paused and you had a wonderful time. You were able to copy down all the notes that you needed to. To start off the second part of this lecture, we're going to talk about, okay, so how do we convert from one unit to another unit? And to help us do that, we're actually going to be using science's favorite subject. Spoiler, science's favorite subject is actually math. Now, I just heard some of you go, no, not math. We're going to start with the most simple part of math. Are you ready? All right, here we go. What is 2 times 1? You got it? Oh, I don't know if you got it. Let me give you another one. These are a little bit tricky. What if it's 0.5 times 1? Still stuck? It's okay to be stuck. Say I have 251 times 1. It's okay if you don't have it yet. We'll do another one. What if we have 4,761 times 1? All right. I understand these are really hard, but let me explain each of these. So 2 times 1 is 2. 0.5 times 1 is 0.5. 251 times 1 is 251. And 4,761 is 4,761. Whew, that was hard math, but we made it. All right, now in each of these cases, if we multiply a number by 1, we do not change the value of the number. So far, so good? Okay. This is called, if you remember from math, this is called the identity property. Now, how does this help us? Well, sometimes we can have fractions that equal 1. If we think about it, if I have 1 over 1, well, that's 1. If I have 3 over 3, well, that's 1. If I have 5 over 5, well, that's 1. In fact, you've multiplied things by these, basically by 1. So I'm going to go ahead and try something here. I'm going to give you a statement, and that statement says this. For every 1 meter, there are 100 centimeters. So to help me see this, I'm going to go ahead and draw out. So if I have a meter stick, Ooh, not evenly spaced numbers there. But if I had this, and on this side I said, okay, my meter stick is 1 meter. It's also 100 centimeters. So far, so good, yeah? Well, if 1 meter is the same as 100 centimeters, then these two are equal to each other. So that means if I was to write a fraction, 1 meter over 100 centimeters, and 1 meter is the same as 100 centimeters, those would equal 1. Because a meter is the same thing as 100 centimeters. I could also say that 100 centimeters divided by 1 meter is also 1. Now you're saying to yourself, Mr. Jacobs, you're hurting my brain a little bit. What do you mean that 1 over 100 equals 1? Well, if you remember your math teacher, and I know they've done this because I've been a math teacher and actually still am a math teacher, they always tell you to put in your units whenever we're working on something. So when we look at this, 1 meter is the same as 100 centimeters, but that doesn't mean that 1 over 100 equals 1. It means that a meter divided by 100 centimeters is a meter. So these two numbers that I just wrote right here, these are called conversion factors. And we're going to go over these a lot more detail when I zoom into class tomorrow. That said, conversion factors, what's a good definition for a conversion factor? So a conversion factor is a fraction that includes two units which equal 1. And to get there, we're going to write these statements here. These, we're going to call these for every statements. So let's look at another one of these. It is a true statement that for every 12 inches, there is 1 foot. Now, whenever we have a for every statement, we can write two conversion factors. So what we're saying is that if I have a ruler, and that ruler has 1, 2, 8, 9, 10, 11, 12 inches on it, that it is both 12 inches and 1 foot. That means that I can write two conversion factors. I can say that there are 12 inches for every 1 foot, and that there is 1 foot for every 12 inches. And these would be the two conversion factors that help me going from feet to inches or inches to feet. Now, tomorrow, we're going to take a look and see how do we use these conversion factors to make conversions. I'm going to go ahead and give you a quick spoiler of how to do that. But before I go there, let's go ahead and I just want you to try on your own to tell me what would be our two conversion factors for these units. So there are 1,000 meters in 1 kilometer. I want you can talk it over with your partner, write the two conversion factors, the two fractions, which are going to be each equal to 1, that we can get from this for every statement. Or really, instead of there are, it should say for every 1,000 meters there are. There is, it's singular. All right, now, the two conversion factors you should have, if you need to, you can pause the video here if everyone doesn't have an answer yet. The two conversion factors you should have is 1 kilometer over 1,000 meters and 1,000 meters over 1 kilometer. Those are the two that you should hopefully have written on your page. Now, how on earth do we use these? Well, let's say I wanted to know, all right, I ran 325 meters today, and I wanted to know how many kilometers that is. Well, 325 meters, we can write that as a fraction over 1. If we look at our two conversion factors here, each of these are equal to 1. So if we multiply it by either one of these, we're not going to change the value of what we start with. So what this means then is that if I want to convert to kilometers, I need to choose which of these two is going to give me a unit of kilometers in the end. So I'm going to pick this one right here because kilometers is in my numerator. Let me show you why. So if I say 1 kilometer for every 1,000 meters, if I have a unit in my numerator and my denominator, those will both cancel. Congratulations, we just saved the Mars climate satellite. Well done, class. So if we do that and we multiply that through, we get 325 over 1,000 kilometers. And if we put that into a decimal, which we like as science, we'll go 0.325 kilometers. And right there, boom, we just converted from meters to kilometers using our conversion factors with our for every statement. Now, if this last part really didn't make sense to you, just make sure you've got this work copy down. We're going to do a lot more practice on this tomorrow. But to kind of sum up, what is it that we're talking about today? Well, what we're talking about is we started off talking a little bit about what are the different ways that we can measure things. We can measure things either in the Old English system or the imperial system, but most scientists use the metric system. In the metric system, all units are in multiples of 10, so we start with a base unit, and then we'll add one of these prefixes to our unit in order to explain how big or small it is from that base unit. Now, we used meters here. It's important to note that you could also use grams or liters for any other SI unit. After that, we talked about how the identity property means if we multiply something by 1, we don't change the value of it. Then we made up these conversion factors, which are really just fractions that equal 1. So that way, we can multiply these conversion factors by a number to not change its value, but to just change its unit. All right, now your homework for tonight. Let me go ahead, you can see my face. All right, so I hope you're having a wonderful rest of your day, and I will hopefully see you guys tomorrow and can answer some of the questions you have on this. Tomorrow, we're going to be doing more practice using conversion factors. So what I need you to be doing tonight is just working on your flashcards. So make sure that your notes are all good, and then go ahead and use your flashcards. So you should have some time hopefully left in this period to start on those flashcards. All right, thank you guys. I hope you're having a wonderful day, and I will see you all tomorrow. Thanks.